This presentation on reciprocating compressors provides basic equipment descriptions and compressor selection criteria, along with guidelines for determining power requirements and designing the associated piping systems. Unfortunately, when gas is produced with liquid, its pressure after separation is often lower than the pressure at the gas transmission line. And it is much lower than the pressure that might be needed in some fields for gas lift or reinjection. In this type of situation, reciprocating compressors are used to increase the gas pressure so that it can flow downstream. A reciprocating compressor increases gas pressure by using a piston-cylinder arrangement to reduce its volume. As the piston moves away from the cylinder head, the suction valve opens, allowing gas to enter the cylinder. As the piston travels the full stroke, the cylinder becomes full with gas. The piston then begins to move back towards the cylinder head, reducing the gas volume. This increases the gas pressure and closes the suction valve. As the piston continues to move, the gas volume is further reduced and its pressure is increased. When this pressure becomes slightly higher than the discharge pressure, the discharge valve opens and gas begins to exit. The piston continues to move to the end of the stroke near the cylinder head, thus emptying the gas from the cylinder. The piston then reverses its travel, and the process repeats. A reciprocating compressor can be either single-acting or double-acting. In a single-acting compressor, only one side of the piston is used to compress the gas, whereas in a double-acting compressor, both sides of the piston are used for compression work. A compressor may have any number of stages. In a multi-stage compressor, each cylinder handles the same volume, but at different pressures. The cylinders are connected in series, and the discharge volume of the first cylinder enters the suction port of the next cylinder, and so on. Each cylinder successively increases the pressure until the desired level is achieved. The number of stages is dictated by the final discharge pressure requirement. A typical compressor consists of three main components: a compression unit, a drive unit, and a distance piece. The compression unit compresses the gas, the drive unit supplies the power, and the distance piece combines the two pieces together. Power for the drive unit is provided either by electric motors or by internal combustion engines, such as diesel engines or gas turbines. High-speed compressors are normally driven by electric motors or by gas engines, whereas most slow-speed integral compressors are powered by gas turbines or by gas engines mounted on the same frame. The rotary motion of the drive unit is converted to the reciprocating motion of the compression unit by means of a crankshaft, connecting rod, and crosshead. Along with the piston-cylinder arrangement, compressors contain such internal components as the suction line, discharge line, valves, cooling jacket, and lubricating systems. Reciprocating compressors are classified as either high-speed or slow-speed. Typically, high-speed compressors run at a speed of 900 to 1200 RPM, whereas slow-speed compressors run at speeds of 200 to 600 RPM. High-speed compressors are built in sizes ranging from 50 to 2500 horsepower, and slow-speed compressors are usually available from 1500 to 13,000 horsepower. The advantages of high-speed compressors are that they are self-contained, can be skid-mounted and transported easily, and are less expensive. On the other hand, slow-speed compressors offer lower fuel consumption, longer operating life, and lower maintenance costs. However, they require heavy foundations, must be field-erected, and usually have higher installation costs. Selection of compressors depends on the type of use and its location. High-speed compressors are mostly used for field gathering and for offshore locations. Slow-speed compressors are common in large onshore fields and for pipeline applications. The text that accompanies this presentation describes reciprocating compressors and their various components in detail, and presents methods for selecting compressors, determining power requirements, and designing the associated piping systems. After viewing this introductory video, please follow the sequence outlined here. First, read the process explanation. Next, review the equipment description. Study the design theory and procedure. Then, work through the design examples.